Hi, and welcome to Calculus Examples. I'm Dr. Finch. Today we're looking at an example where we're finding the limit as n goes to infinity of 2 plus negative 1 to the n over 2 to the n. I just thought this was a really cool example. I wanted to throw this up here because the way that we're going to think about this is a little bit different. I know we're used to putting n in and seeing what happens. I want us to kind of see what's going on, and so we're going to think of this as a sequence. And we're going to say, okay, my sequence starts with 2 plus negative 1 to the n over 2 to the n. And as we move on, we're going to get different elements of our sequence. So let's start with S1 and see what happens there. So that's 2 plus negative 1 to the first power over 2 to the first power. So that's 2 minus a half. So the first number in our sequence is 3 halves. As we progress, so now S2 is going to be 2 plus negative 1 squared over 2 squared. So we get 2 plus, now negative 1 squared is a positive 1, so there's no negative this time, and over 4. So another way of writing this out would be 8 over 4 plus 1 over 4, or 9/4. So you'll notice that our first number is actually less than 2, right? And our second number is actually bigger than 2. What happens when we get to our third number? So now we get 2 plus negative 1 cubed over 2 cubed. So now 2 cubed, or negative 1 cubed, is a negative. So we're subtracting now, and 2 cubed is 8. And if we do the math there, and I'm just going to do that quickly, it's going to give us 15/8, and we are again less than 2. So because there's that negative sign, if we went through and did S4, we get something that is bigger than 2. We're actually flipping back and forth along the number line of 2. So here's 0, here's 1, here's 2. We start off, here's S1 at 3 halves. And then we get, S2, which is a little bit bigger, 9/4. And then we get S3, which is over here. I'm not going to put those numbers in. We get an S4. And so you can kind of see that we are converging on both sides of 2, but we're jumping back and forth. So it's not acting the way we normally see limits act, but it's really cool in that way. As n goes to infinity, we notice that 2 to the n also goes to infinity. So that tells us when we're looking at things like a negative 1 over 2 to the n or a positive 1 over 2 to the n, both those numbers are going to go to 0 because our denominator is going to be blowing up, right? When our denominator gets really big, the number itself, 1 over that denominator, gets really small. And what's stuck between these two numbers here is our negative 1 to the n over 2 to the n. Now you'll notice one thing I did tack on. I put a or equals to because it flips back and forth. It's going to be one or the other number. And it is definitely stuck in the middle, which means, ta-da, this is one of those weird places where we are actually using the squeeze theorem. That is not using a trig function, that is. Usually it's always trig functions. So by the squeeze theorem, the limit as n goes to infinity of 2 plus negative 1 to the n over 2 to the n. We know that this second term goes to 0. So the whole thing itself goes to the number 2. And I hope you enjoyed that cute little example. Thank you for listening.